The goal of our project was to estimate wait times for taxicabs in New York City by location, time, and day of week. This information is important for consumers to make trip decisions and better understand how long it will take them to reach their destination. The data that we used for this modeling was taxicab data from the Taxi and Limousine Commission, which is publicly available online. We calculated the wait times by aggregating the trip data and using the aggregates to calculate supply and demand for taxi trips. From the supply and demand values, we calculated weighted inter-arrival rates for cabs, assuming a Poisson distribution for the trips. Once the inter-arrival rates were determined, the wait times were estimated by calculating means on simulated arrivals of taxis for passengers. Finally, once the wait times were estimated, the data was handed off to our front end, which displays heat maps of supply and demand and wait time calculations across location, day of week, and time. This data is loaded as a flat file to the front end. The front end manually maps the taxi locations to latitude and longitude coordinates and displays the heat maps through an open source library called DecGL. To our knowledge, this is the first time that wait times have ever been estimated for taxi cabs. In our research, we saw that this method had been applied for estimating wait times for public transportation, but never before for taxi services. Some of the experiments and questions that this project set out to answer include: what size should the time buckets be for our modeling? How much data should be used? What UI visualizations are best for representing this data? What frameworks are currently available to best implement these visualizations? And most importantly, how can we determine the accuracy of the models? We validated the accuracy of the models in two different ways. The first was asking ourselves if the wait time estimates passed a sniff test from our New York City residences, which they did. The second method was to test the validity of our assumption that the data fit a Poisson distribution. We did this by building a Poisson regression model and compared it against a more generalized negative binomial regression model. By doing this, we observed that the data did not match all of the assumptions that a Poisson model makes, leading us to think that we could have generated better wait time estimates with more generalized models. We also observed the generalized model to have better fit according to various metrics, including AIC, log likelihood, deviance, and Pearson chi-squared. Now, let's take a look at the application itself. As you can see estimates for supply and demand and estimated wait times for a given location, time of day, and day of week. This application could help consumers make more informed decisions regarding modes of transportation. Thank you.